Hi lads, this video is going to go through question 11.9 on page 112 of your booklet for today's class. It tells the design for a toy submarine is given. The curve AVB is a parabola, so basically here, that's a parabola there, with the vertex at V, so there's our top point. AC is a tangent to the circle from A, so the line then running from A to C, which we're not given, we have to figure that point out. It's going to be a tangent to that circle. So we know a tangent is a line that touches a circle at one point only. And it tells us basically draw the given design. So the first thing I'm going to do is I'm going to start off by drawing my center line here. So we're not given an actual starting point. I'm going to go roughly about, see what I measured there. I went from the bottom of my page roughly up about 95 mil. And that's going to be my center line there. So the first thing I'm going to do is I'm going to mark off this point here, being the center of my circle. And just roughly in, lads, that's about 70 mil, I set that there. So the circle, you can see there, it's going to be a radius of 50. So if I set 50 mil there, that's the radius of my circle. I'll start off by drawing in my circle first, so just do it lightly. After that then, I have a radius 15 circle. So set my compass to 15 mil. And draw in my circle, that one there. And then from this end here, out to the line AB, it's 105. So I can set 105 mil there. And I can draw that line vertically. And I can see the width of my box that's going to fit my parabola is going to be a total width of 80. So I need to go up 40 and down 40. And I can take two horizontal lines there and there. And then it's going to be a further 70 mil then. So now what I have is, I have point A here, point V there, and point B there. And my parabola is going to be going in that direction there. So, as usual, I'll divide my side here first. I'm going to divide it into 4 equal parts. So take a line at a random angle, take a random distance and step it out 4 times. 1, 2, 3, and 4. And we use slide and set squares to connect those. So if you want, you could divide into 5. I just picked 4 because the box isn't exactly that big. So there's my side. I know because my curve is starting from here, there's the top point. All of my side measurements, they all connect to V. Now I can divide this side here into 4 equal parts. And remember, we only go halfway across. So we're going to be only going stepping out to V. So we step out 1, 2, 3, and 4. Connect that back to V and take parallel lines again. I can label that 1, 2, 3, 1, 2, 3. I can see here 1 connects to 1, 2 connects to 2, and 3 connects to 3 there. And what I have now is, I have all my points to draw my freehand curve between B and V, And then just like I've always done before, it's going to be a mirror image. So I can step 3 across, 2 across, and 1 across. So taking this distance here, step that across, that gives me 1 on the far side. Take this distance here, step it across, and then finally for 0.3, step it across. And now what I have is, I have my opposite points, drawing my parabola there. And I can see from the question, the whole parabola is drawn in heavy. For the line connecting A to B, that's not heavy. And I can also see there's a radius 15 there too. So I can take that radius 15, step it out to here, and I can draw that in. I then have a line going through V here. You can see there it's a vertical line. If I just move this up a bit, it's going all the way through, and it stops in line with A and in line with B. So it basically runs like that there, and then it's stepped in 15 mil. So 15 mil there, dot at the top, keep that 15 mil. And then I can see that it's inclined at 60 degrees. So I have 60 degrees going in this way. It's only heavy up to the parabola, and 60 degrees going this way. You can see that line up, and once again, only heavy up to the parabola. The next part we'll do is I'll do the tangents. So you can see it's going to be a tangent running from A to touch a point on the circle here. It's going to be point C. We don't know where C is. So this is from a previous chapter. So we're looking at other chapters once again. To draw a tangent to a point outside a circle, we join the tangent point to the center of the circle we're drawing. So A there connects to that point there. And we bisect that line. So taking a distance greater than halfway, swing an arc above and below each side. Where they cross, join them together, and then draw your semicircle. Where the semicircle crosses the circle, that's our tangent point. There's point C. We can now connect A to C, and then the curve will go all the way around the rest of the way. And because it's the same on the top and the bottom, we can very simply take point C down to give us point D below there, and connect B to D. You could also join the centers, bisect it, draw your semicircle, you get the same result. I'll now draw the outline of this circle in heavy. And then the other two circles are already heavy enough. And the last thing I have then, I have a 60-degree line going from the top of the circle here. So you can see that line going straight up. I'll just move this up a bit so you can see it. Goes out 60 degrees. The height where it stops after the 80, you can see there, it goes a further 30, and then 10, and 10. I can take those across there, and my 30mm line here is where that 60-degree line stops, just like that there. And I can see at this point it's 10, 10, and 10. So it's a combined total of 30, 10, 10, and 10. That gives me my end point there. And that then connects back to that point there at A. And I can see it goes up heavy there, there, and it goes across, up, over, and then it's a curve then. So it's just a quarter circle there. So it's basically just the radius between there and there. And that's then the question finished. So hopefully that video helps anybody who would have been stuck on that question there.